before I start, I have two things. The first is I was thinking back about talks I've done in the past, and the first camp or like public talk I ever did was at Puppet Camp in 2010. So it's a huge honor to be back. And I also just moved back from Bhutan, so I've been here for 3 days, so I'm super jet lagged. So sorry if I like zone out while I'm talking or something. But yeah, so I'm going to be talking, oh, sorry, that was one announcement. I have another announcement. My other announcement is I'm the maintainer of Puppet 2.7. If you're on 2.7, please migrate off of 2.7 to 3. I'm EOLing at September 30th of this year. After that, good luck with the patches. Have fun. But yeah, like seriously, there's no excuse anymore. It's been out for almost 2 years. Upgrade. So, now that I've gotten that off my chest, I'm going to be talking today about continuous deployment in Puppet. I work at DigitalOcean, which is a public cloud provider based here in the city. I wanted to say thank you to them because I started there yesterday, so thanks for letting me come. And also hiring me. So DigitalOcean, if you're not familiar, is a pretty cool public cloud provider. We're also hiring. We have beautiful offices in Soho. So talk to me after this or at the bar or something if you're interested in that. Continuous deployment has been around for a while. People have been doing it for a super long time. But for some reason we didn't have this word for it until like 2010. I blame Chris Baytart, but like, whatever. Lots of people before him, Jez Humble and other ThoughtWorks people have been talking about this for a while. And so I just wanted to talk about why we actually care about this thing and also what it is and how to do it with Puppet. It's usually referring to software, and at the end of the day, you know, people who are writing Puppet stuff, writing Puppet modules and building environments out of Puppet are really writing software at the end of the day. You're building these systems that have to integrate with one another, and they end up being pretty complicated. So we all suddenly seem to care about this thing for a few reasons. The big one is this word that I made up all the words that I'm about to say. The big one is this deliverability thing, which is really the idea that you can get something from hopefully a Git repo out into a real environment or ship to customers depending on how you deliver. Basically, the fundamental thing behind this is the idea that we can have something and take it from some, you know, a repository and produce the end product from it, whatever that is. This is another kind of, it's something that we think about a lot less, but it's the ability to change systems. One of the great things about Puppet is, you know, I've managed Puppet environments with hundreds of thousands of machines, and in those environments, we could roll big changes out in 10 minutes. And so the ability to actually take something, alter it, and then like push that out is a huge deal. And there's recently been this hot topic of immutable infrastructure. Chad Fowler, who used to work at Living Social and now works at a company called, it's German, they make Wunderlist. I can't pronounce it. They make Wunderlist. He came up with this idea of immutable infrastructure. And the idea is that you're taking a system and that system's going to run with, you know, whatever configuration it has, whatever code it has on it, and that's going to get shipped. And then when you change it, you don't actually change the running machine, you just spin up a new machine. And it introduces lots of interesting problems. In a lot of ways, Docker has become this thing that everyone is obsessed with for this reason, right? You can build this container, despite the fact that LXC has been around since like the 2.6 kernel, which is ancient. You know, Docker kind of introduced this new idea that for some reason we have to like always build new machines. I don't necessarily disagree with it. I think everyone needs to calm down about Docker though, so I'll just say that. And I think the fundamental kind of thing to keep in mind here is that what you're delivering, whether it's you know, an image, you know, maybe your company builds appliances with Puppet, Or whether it's a package, right? So maybe that package contains all your Puppet modules and then you push it out to a central repo, or an appliance, which is kind of whatever, or entire environments. Increasingly, things like CloudFormation and in the OpenStack world, a project called Heat, which has kind of superseded and gotten a lot better than CloudFormation. These are the kind of things where we can build entire systems in one drop, right? So you say, hey, I want to run a system that looks like this. It has Postgres database, 10 app servers, 3 load balancers that we DNS round robin to, and spin it all up. And so we actually have these big things that we need to test and deliver and make sure they always work because we have to give a shit about our infrastructure. Hopefully. And fundamentally, Puppet is really important to this process because configuration of whatever you're building is the heart of the build process, right? Configuration is, you know, I don't really care about like an OS distro right after installation. I just don't. Although I worked on RHEL before I worked at DigitalOcean, so I kind of do. But like, you know, the configuration is really what we actually care about. We care about all the stuff on top. Increasingly, the OS is bullshit that's getting in our way. And projects like CoreOS are saying, hey, this is dumb. We don't actually need 40,000 packages in the distro repository because we don't actually care about the fact that, you know, like, we don't, increasingly, I guess what I'm trying to say is increasingly the OS doesn't matter and we care way more about all the stuff that's running on top of it. And, you know, I could go on a packaging rant. Seriously, working at Red Hat will make you go on packaging rants. So immutability has become this big thing, is my point. And configuration of whatever we're running is a big part of immutability. The problem is, doing immutable infrastructure work means that we have this whole problem of, if everything's immutable, how do we actually ever configure it, right? So if your load balancer is immutable, how do you know which app machines run behind it? If your database is immutable, how do you actually like get data onto it, right? Like there are things that have state. And even stateless systems often hold state, right? If you use Java, your systems hold state because your daemon's running and the JVM takes like 45 minutes to boot. So, like, you know, stateless systems actually take a lot of effort to get into a stateful position. Even a stateless system, like if you run big memcache clusters, you think of caches as immutable and things that can go away. But at the end of the day, if your entire cache was cleared, could your database actually repopulate all the objects that lived in it? And most could not. I mean, even smaller systems. I worked at a company called Venmo in New York in the early days of the company, and we had like a total of probably, across 10 machines, we probably had like 50 gigs of object cache. And one day, I rebooted all the memcached with mcollective, and we were in some trouble, right? So even though we think of the fact that we have statelessness as a fundamental principle here, it really, and you know, we try to build microservices now. A lot of companies at least try to build microservices now that don't hold very much state, right? They know about what they're going to take in and what they're going to give out, and you know, maybe they use a messaging system to talk. So stateless systems do fundamentally hold state, and immutability at the end of the day is really hard because of that. And we also don't have, let me continue, we don't have good orchestration systems yet, right? We think about Puppet sometimes as an orchestration system, or mcollective as an orchestration system, but at the end of the day, real-time orchestration, right? Where you have, if you have big infrastructure, you have thousands of machines or tens of thousands of machines, orchestration is really, really hard, right? How do we get these machines to know which are the other machines they should be talking to, and all this stuff? So, the moral of the story here is that doesn't matter. Single node convergence right now in the world we live in today does not matter at all, right? We don't actually care if Puppet can run on one machine. because our goal is that we have all these different roles that actually work together, right? We actually care about multi-node orchestration. We care that our app servers can talk to our database. We care that our load balancers know which app machines live behind them. And fundamentally, when we miss this, we're in trouble, right? I don't know if any of you have a one machine production environment, but you're really fucking lucky if you do. This is really simple, right? We're registering a Nagios host with an exported resource into PuppetDB or whatever. If you're, again, like, migrate to PuppetDB if you're still using the active resource-based thing. But this is really simple, actually, right? We're just telling, we're going to collect it on another node, say, give me all my resources, and then we're going to restart Nagios, because that's how Nagios rolls. And so we're going to restart Nagios, and we'll have a machine in monitoring. That's not even like time critical, right? We don't actually care about that, but it's multi-node orchestration. Also, you should care about monitoring, so that's a lie. Isolation is this, if you write application software, you know a lot about isolation, hopefully, because you're writing tests that run in isolation. But isolation to us, infrastructure people, doesn't really matter that much. We don't actually build systems in isolation. We don't build one machine in isolation. So we need good tools that will let us get deliverables out the door, right? We need tools that will help us actually test and make sure the thing that we're delivering isn't crappy. Before I talk about any of the tools, I didn't even want to talk about tools, but it's hard to rant for this long without getting out of breath. So, I just wanted to say, before I talk about tools, humans are really bad at doing things over and over again. We make lots of mistakes. Our brains aren't wired to do things over and over again. Run this stuff that I'm about to talk about via Jenkins or Drone or whatever. Do something with it. Let the computer do the work for you. You do the thinking. The computer will do the repetitive task. But the tools that I'm about to talk about are all really important to kind of building out complete systems. So whatever works for you, use it, but don't do this stuff by hand, please. So we probably care about whether it works. If you haven't checked it out yet, there's a pretty cool Ruby testing framework called RSpec. Actually, like half the things I talked about were written by a pretty awesome dude named Tim Sharp. So he's at Rojek on Twitter, so tweeted him, thanks for his stuff. But he wrote RSpec Puppet. He also wrote some of the other tools I'm going to be talking about. He's Australian and he's cool, so tweeted him. So RSpec Puppet lets you do unit testing. These are isolation tests, right? So you're basically checking, hey, I want to install a module, and I want to make sure that when I add the Apache module to a node, that it actually installs Apache. So, if I'm on RHEL, it's called HTTPD. If I'm on Debian, it's called Apache 2. So this lets you basically say, am I getting the right stuff on this type of node? Beaker is another pretty interesting project. It replaced an older project that was worse, so that's great. It replaced an older project that Puppet Labs worked on, and it essentially actually does node convergence inside of a Docker container or a virtual machine or on a public cloud. It's pretty cool if you haven't checked it out yet. Increasingly a lot of the Puppet Labs modules are using Beaker to actually test across all these platforms, right? If you're someone who's responsible for delivering stuff that works across lots of OSs, lots of architectures, on lots of different hardware, you should probably check out Beaker. It's pretty cool. There's also, it's based a little bit, some of the ideas are coming from a project called Test Kitchen. Some Puppet Labs employees were working on making Test Kitchen comes out of the Chef community. A lot of Puppet Labs employees, or a few at least, James Turnbull was kind of leading the effort, but now he works at Docker, so whatever. He was kind of leading the effort, and he was working on making Test Kitchen completely decoupled from any configuration management. So he actually got pretty far, but no one has written the Puppet bit yet, so there's a chef bit, and there's an abstract framework for doing execution and convergence testing. So, like, I'll give a bunch of money to whoever writes the Puppet bit. Not really, I'll give you like 30 bucks. But there's, there's all this stuff out there. Beaker's kind of emulating Test Kitchen in a lot of ways, but Test Kitchen has a big community around it, and it would be cool to see Test Kitchen kind of become the canonical thing instead of Beaker. Although I think Beaker's great just as an intermediary. Also, like, this command works pretty well for checking if your nodes converge. If you've never used it, this runs the Puppet agent on a node. It's pretty cool for checking if production works. Yeah. And, one of the things is that, and this is talking kind of under the context of delivering machines that you control. I know a lot of people are using Puppet increasingly to deliver kind of like appliances or systems that you run on a base system, and it gives you all the stuff on top of it, like Puppet Enterprise or Foreman both kind of do that, where you take a machine and then you install the software that you need to actually manage Puppet using Puppet on top of it. So I'll talk about that actually in a bit, and some work I did in the Foreman community with some other people. But one of the big questions is, how do we get stuff live, right? How do we actually deploy our changes? Because we care about being able to deliver end user changes. So Capistrano, if you've never used it, is a deployment system that was written by James Buck. He basically came up with the idea that there should be a DSL for deployment. It's pseudo like the Puppet DSL, right? It's not, it runs on top of the Ruby interpreter, but it's not Ruby, although you can write Ruby and load it in as a library, just like Puppet. But Capistrano is a really powerful tool. It supports rollbacks by default. It interacts with Git. It has stage support now. And it's really powerful for actually getting changes out. So if you need an abstract deployment framework, Capistrano is pretty awesome. You should check it out. R10K is a new project that Puppet Labs are working on. It's really, really cool. I'm pretty excited about it. It solves a problem that has existed in the Puppet community for way too long, which is a canonical, supported way to deploy changes to your Puppet masters. There hasn't really been a great answer for this for a long time, and so people have done their own thing. They've used Capistrano, or they've, I don't know, downloaded tarballs onto their Puppet masters. Don't do that. And basically, R10K is aware of Puppet environments. It supports branch deploying, which is pretty cool. So you can basically set up an environment per branch in from a Git repo. So if you're working on adding a new feature, you're working on migrating from Apache to Nginx, you can deploy the system. You'll have a new environment from the branch you're working on. So if you have a branch called Apache to Nginx, it will give you an environment. You can change one node over, or however many you wanted to test, and then you can flip that node over, and then actually test the changes. So it's really useful. I think there have been past talks about environment management with Git, but it has a lot of very useful features that we are going to need and have needed for a long time. And Adrian Debo, I think, is kind of spearheading that effort, so awesome people working on it too. And this is a project that came out of the Foreman community. If you're not familiar with it, Foreman is an external node classifier reporting and provisioning tool for Puppet. There's also some other config management frameworks are starting to kind of get support with it. But kofo is a tool that came out of the problem of how do we install Foreman onto basically blank or minimally configured base nodes. And it basically is a runner around Puppet. So it uses Puppet apply, and it has lots of nice reporting tools. It has support for doing things like prompting a user and asking them questions, right? So things like, what's the FQDN of the node I'm about to install? Because you need that to set up the root cert for your CA infrastructure. Or, do you want X, Y, or Z features? So if you're doing kind of application installation work with Puppet, you should check it out. It's a Ruby gem. It's available on Ruby gems. And you can, it works really well for just installing a base node where you're shipping it to an end user and you don't actually know what the configuration is going to look like. It uses param classes, so it's also kind of pseudo-proper, which is great. And then, the last question is, if you have a production environment, does it actually work in production? And a lot of people do this, but sometimes they don't. And I think it's a really nice pattern, so I'm just going to talk about it quickly. Most monitoring systems support active checks, which are basically the monitoring system talks to a machine and runs a check. Right? The monitoring system itself requests that a check runs. You can run Puppet that way, right? If your Puppet runs are failing in production, something's wrong and you need to fix it, just like if a service is running slowly or something. Probably not with the same urgency, but you actually really do care, and you should care if your Puppet runs aren't running in production. You can also do things like, this is kind of janky, but it's a useful example. Do things like writing out the first time you do a Puppet run, and then checking how things change so that you can then report on it, right? If your machines are falling out of compliance over and over again, someone's probably doing something nefarious. And then the last and kind of least important question, I think, and we don't really have a great definition beyond the Puppet style guide of how proper a Puppet module or a system is, but Puppet lint is a pretty cool tool. It's also by that guy Rajek, and he wrote the tool basically keeping in mind that you don't always have the same rules, so you can tweak rules and stuff like that. But it basically, you just run it over your manifest and it tells you style violations. You can, as I said, change what you think is a style violation. It's pretty nice. I like to run it on Git check-in so you can actually see if your style has gotten worse or better. And it helps people when they get an email saying, hey, it's not the end of the world, but you use double quotes instead of single quotes without variable replacement. Stuff like that can be useful to kind of make sure that you have consistent style across your entire code base, even if you have lots of people working on it. So, recap. The three phases that we really want to go through, and just keep these in mind, are you want to integrate changes, validate them, make sure that they work, and then deliver them. And use the tools that make the most sense for you. That's all I've got.